Assalamualaikum warahmatullahi wabarakatuh. We are from Group I, and in this video presentation, we will present about our project, which is Doorbell System Buzzer. In this video, we will talk about the introduction of our project, system architecture, software project, source code, and lastly, the conclusion of our project. The Doorbell system with buzzer using the Intel Galileo Gen 2 is a modernized solution aimed at revolutionizing traditional doorbell systems. This project integrates advanced features such as remote monitoring, automatic notification, and access control through IoT capabilities. The plan of the projects cover hardware and software aspects, detailing the project's objective, methods, requirements, specification, and also assembly code. With the discussion of advantage, disadvantage, and limitation, this project demonstrates a thoughtful approach to enhance the door access controls and also emphasize continuous improvement for future enhancement.
Thank you, Ainin. Now I will present about system architecture of the doorbell system buzzer. First, the system component has four. First, user interface module, Intel Galileo Gen 2 control unit, connection module, and the notification system. So the next is system operation. We have two, input and also output. The input of this project is doorbell button press, generate the signal, and the signal received by Intel Galileo Gen 2 board, and then it will produce the output. Buzzer activate as a response to the button press as to produce some sound when the button is pressed. So next is system functionality. How the system will function. So it will notify the occupant when someone is at the door, and doorbell button press trigger the Galileo to activate the buzzer by sound, and also user awareness to enhance through the notification. That sound of the buzzer will notify the occupant in the house. So lastly, about the operation flow, has five flow. We first doorbell button press the generate digital signal, which is high and low, 1 and 0. Second, Galileo board will process the input signal. Next, the Galileo board trigger the doorbell response, and output signal activate the buzzer sound from the button press, and the output signal activate the buzzer sound to notify the occupant. I said that's now. And lastly, buzzer sound indicate someone is the door, and inside the house will notify was have people outside of the house. So that's it for system architecture. Now I will pass to Faiz.
Assalamualaikum, my name is Abdullah Faid bin Ahmad Kamal. My ID number is 214745. I'm going to present about software flowchart for our project. In visualizing the functionality of our doorbell system with buzzer, we have condensed the intricate operations into a clear and intuitive flowchart. The journey begins with a system initializing, encompassing the setup of the Intel Galileo Gen 2 board, components connection, and GPIO pin configurations. The heart of our program lies in the main loop, where we continuously monitor the state of the doorbell button. If the button is pressed, we seamlessly transition to the button press process, triggering the buzzer by setting the pin bus GPIO register to high. Conversely, if the button is not pressed, we ensure a quiet state by setting pin bus to low. This loop ensures the responsiveness of our doorbell system, making it an intelligent and efficient solution. The flowchart vividly illustrated the logical sequence of events, emphasizing the user-friendly and robust design of our project. I'm going to explain about our assembly language for our project. In this assembly code, we're orchestrating a simple GPIO control system specifically tailored for the x86 architecture. Our focus is on a doorbell system where a button pin SWI trigger a buzzer pin BUZ. We initialize the GPIO pin and set up the memory access using system calls, preparing the groundwork for GPIO interaction. The main loop constantly checks the status of the button. If it's pressed, the system set the GPIO pin to set the buzzer to high. simulating the activation of the doorbell. On the contrary, if the button is not pressed, the buzzer pin is set to low, simulating the deactivation. The code cleverly utilizes a flag BOTAO to detect the button presses, and the main loop ensures continuous monitoring of the button state. This concise assembly code demonstrates the fundamental logic of our project.
To conclude, Doorbell system with buzzer that make use of Intel Galileo Gen 2 show an advancement in door access control system with its ability to handle the signal processing and communication tasks efficiently, and also provides a reliable responsive platform to control the doorbell system. It can also be programmed and customized to integrate with other smart home devices or systems, which can enhance the overall functionality and convenience of the doorbell application system. With this functionality of system, we can see that we can make use of it to enhance the security system of the house and also for the future advancement of the IoT field in the future.